In today's lesson, we're going to talk about what are called limiting reactants, okay? And let's just go back up here real quickly. Let's look at this balanced equation. According to this, well, let's look at a different one, actually. According to this balanced equation right here, there's a 2 right there, sorry. We need 2 moles, according to what this says, we need 2 moles of ammonium chloride to react with 1 mole of calcium hydroxide. Okay, and what happens, though, in our chemical reaction if we don't have 2 moles of ammonium chloride? Let's say we only have 1.5 moles of ammonium chloride. And remember, when we say 1.5 moles, we can convert that to grams to figure out exactly how much NH4Cl we're going to need. Okay, what if I only have 1.5 moles of NH4Cl and I have a full mole of calcium hydroxide? Well, hopefully you realize that for every 2 of these, you need 1 of these. So if I only have 1.5 moles of ammonium chloride, then I don't need that full mole of calcium hydroxide. Well, what if I do have a full mole of calcium hydroxide? Well, then I'm going to have some calcium hydroxide left over. Okay, just like in any chemical reaction, a chemical reaction happens and continues to happen until one or both of the reactants is gone. Okay, and so a lot of times in a chemical reaction, most times in a chemical reaction, one of the reactants doesn't get used up all the way. And what happens to that reactant? Nothing. It's just still there in the reaction mixture. Okay, so the reactant that does run out, the one that does, again, make the reaction stop, is called the limiting reactant. And obviously that makes sense. It's the reactant that limits how far the reaction can go. Okay, the reactant that doesn't get used up, the one that gets left over and is still just there in the reaction mixture, is called the excess reactant. Okay, well, how do you know which one of those it is? Well, you have to do some math. Okay, in order to do some math, you have to be able to convert from one reactant to the other reactant. Okay, and so in order to determine this, we have to use we have to figure out which one's going to run out first. Now, first of all, let's back up even more. How do we know a problem deals with limiting reactants? Because a lot of times in a chemical reaction, all the stoichiometry problems we've done before have not been limiting reactant problems. Okay? So, for example, in this case, there's only one reactant. Okay? So, of course, BaCO3 has to be the limiting reactant. Okay? And in this case, when they only give you the amount of one reactant, or even in this case, one product, you know it's not a limiting reactant problem. Okay? What mass of zinc? Again, they're asking you how much of that zinc you need to react with all of that. Okay? So a lot of times, especially when they only give you the amount of one of the reactants, it's not a limiting reactant problem. Okay? It's when they give you both of those reactants, that's how you know it's going to be a limiting reactant. Okay, so that's what this paragraph says here. A lot of chemical reactions, you're not going to have to find the limiting reactant. Okay, how you determine it? Again, if the problem states that one of the reactants is an excess, well, then they're telling you this is the excess reactant, therefore the other reactant is the limiting reactant. Okay, if the problem gives you quantitative, which means numerical data about 2 of the reactants, then again, that's a good indicator that it's going to be a limiting reactant problem. And of course, if it says, what's the limiting reactant? It's a limiting reactant problem. Okay, once you've identified the problem as a limiting reactant problem, then here's what you have to do. You convert from the given information of one reactant to the given information of the other reactant. And then compare how much you have, which is the number given in the problem, to how much you need, which is the amount that you calculated. Okay, let me show you what this means. Okay, 2 nonmetals, sulfur and chlorine, react to the equation, according to the equation below. 202 grams of sulfur are allowed to react with 303 grams of chlorine in the reaction above. Okay, so right away you should recognize that, oh, they're giving me the amount of sulfur and they're giving me the amount of chlorine. This is going to be a limiting reactant problem, unless they tell us something later. So first of all, we need to balance it. So to balance it, there's 1 sulfur, 1 sulfur. We just need to put a 3 right there. So it's S plus 3 Cl2s makes SCl6. Identify the limiting reactant, and you have to show math to do that. You can't just say, this one's going to run out first. sulfur is the limiting reactant because there's only 202 grams of it. That's not correct. Because remember, it's not the grams that react. It's the particles that are reacting. Okay, so what do we have to do? It doesn't matter how you do it. You just start with one of the reactants. So I'm just going to start with 202 grams of sulfur. And what I'm going to try to do is I'm going to take my mass of sulfur and figure out how much chlorine do I need to react with all of that. Okay, so just like every other stoichiometry problem we've done, 32.1 grams in 1 mole of sulfur. You could use 32.06, that's fine. And then according to the balanced equation, 1 mole of sulfur. And remember, I'm going to go to the other reactant. So is going to react with 3 moles of chlorine. And then again, 1 mole of chlorine has a molar mass of right around 71 grams. Okay. So now I'm going to take 202.0. I'm going to divide by 32.1. I'm going to multiply by 3. And then I'm going to multiply by 71. And I get an answer of 1,340 grams of Cl2. Okay. Now, what does that number tell me? It tells me something really, really important. Because here I have 303 grams of chlorine. Here it's telling me I need 1,340. Do I have enough chlorine to react with all of that sulfur? Absolutely not. Okay, because I would need over 1,000 grams of chlorine to react with those 202 grams of sulfur. And again, I don't have it. And since I don't have enough chlorine, I only have 303 grams, what that's telling me is that the chlorine is going to run out first. Because if the amount you need is more than the amount that you have, then you don't have enough. And if you don't have enough, that's telling you that chlorine is the limiting reactant. And again, the reason that's important is because that's telling us that's when the reaction's going to stop. Once you've used those 303 grams of chlorine, the reaction cannot continue anymore because guess what? All the chlorine is gone. Okay? Now, why does that matter? Because now the next question is how much SCl6 is going to be produced? Again, what's limiting this reaction? What's keeping this reaction from going any farther is, again, our amount of chlorine because that's the limiting reactant. Remember, even though we have more chlorine, even though we have more mass of chlorine, remember that we need 3 moles of chlorine for every 1 mole of sulfur, and the molar mass of chlorine is way bigger than it is for sulfur. Okay, so we need a lot more chlorine than we actually have, so that reaction is going to stop based on those 303 grams of chlorine. So, when you're figuring out how much product is going to be produced, what do? You have to use the limiting reactant. Okay, what do I do with this 202? Nothing. Okay, I don't do anything with it because that's going to be left over. There's going to be some of that left over, and we're actually going to calculate that here in just a minute. Okay, so how much product is going to be produced? Remember, you can't use this number. This is just theoretically how much chlorine would you need. You use the amount of the limiting reactant you actually have. So we have 303 grams of Cl2. And again, every time you do this, don't forget that there's a 2 there. So you have to double that mass. Chlorine's 35.5. Double that, that's 71 grams in 1 mole of Cl2. And then from the balanced equation, 3 moles of Cl2 are going to make 1 mole of SCl6. And then again, they want to know the mass of SCl6. So my last step is going to be the molar mass of SCl6. So I'm going to take 35.5 and multiply it by 6. And then I'm going to add 32.1. And I get in 1 mole of SCl6, there are 245 grams. Okay. And now we just go to the calculator. So we take 303, divide by 71, divide by 3, and multiply by 245, and we get around 348.5 grams of SCl6, and that is our final answer to that question. Okay, part D. What mass of the excess reactant will be left over?
So if we might have gotten lucky, we didn't in this case, okay? Because if we had started with chlorine and figured out sulfur, it would have told us how much is going to be left over. Because remember, when you're figuring out the limiting reactant, it doesn't matter which number you start with. I could have started with the 202 grams of sulfur and converted to chlorine like I did, or I could have started with the chlorine and I could have converted to sulfur, which unfortunately now I have to do in order to figure out how much of the excess reactants left over. So I'm going to go 71 grams in 1 mole of Cl2, and then from the balanced equation again, 3 moles of Cl2 react with 1 mole of sulfur, and then 1 mole of sulfur has a mass of 32.1 grams. Okay, so 303 divide by 71 divide by 3 times 32.1 equals 45 point, well, let's just say 45.7, since they have one number after the decimal point as well. Okay, and again, what does that tell me? If I had started with that number, it would have told me again that I need 45.7 grams of sulfur to react with all of this chlorine that I have here. Okay, but how much sulfur do I actually have? I actually have 202 grams, but I only need 45.7 of it. So imagine like making a recipe where you need 200 grams. Let's say you need 4 cups of something, but you really only needed 1 cup of something to react with everything. Well, you're wasting a whole bunch. We're wasting a whole bunch of sulfur here that we don't need. Because how much is going to be left over? Well, if I start with 202, but I'm only going to end up using 45.7, because remember, once all this chlorine is gone, what is the reaction going to do? It's going to stop. So you're going to have a whole bunch. You're going to have 202 minus 45.7. You're going to have 156.3 grams of sulfur left over. Okay? Now remember, sometimes when you get to this, if there is that question, how much of the excess reactant is left over? Sometimes remember here, we got the limiting reactant was chlorine. If we had done it backwards, if we had started with Cl2 and gotten sulfur, we would already know that answer. We could have just taken the 202 and subtracted the 45.7. We didn't, and so we had to do another step to do that. But just know that sometimes you can do that. Okay, example 2. How many moles of Cl2 are produced when 20 milliliters of acidified 0.2 molar KMnO4 is added to 50 milliliters of 0.10 molar NaC2O4? Okay, so again, notice they're giving us the amount of both reactants. They're giving us the potassium permanganate and the sodium oxalate. Okay, so what do we need to do? We need to figure out which one's going to run out first. So again, it doesn't matter which one you start with. I'll start with the KMnO4. And again, they've given us concentration and they've given us volume, so we can go right to moles. So 0.20 times 0.02 liters equals, so 0.20 times 2 would equal 0.40. But now we have to move that decimal point 2 spaces to the left. So that's 0.004. See how I did that? Is I did it and a number I knew the answer to. I knew 0.2 times 2 would equal 0.4, but it's not times 2. So I thought, oh, well, here, 2 spaces to the left. So I moved that decimal 2 spaces to the left. So we have 0.004 moles of KMnO4. And then using the balanced equation, this is a net ionic equation. They took the potassium and the sodiums out. So 2 moles of KMnO4 are going to react with, and it's the oxalate, the C2O4, with 5 moles of C2O4 2-. And again, we could get grams, but remember, they've given us concentration and volume here, so we're going to get moles of that one as well. So 0.004 times 5 would be 0.020. Again, this is a multiple choice question, so no calculator. That's why I'm doing it this way. Okay, so 0.004 times 5 would give us that, and then dividing by 2 cuts that number in half. So 0.010 moles of C2O4 2-. And again, that's how much I need. Okay, now let's go back to here. Let's look at our actual problem. Our concentration is 0.10 molar, and we have 0.050. Okay, and anytime you multiply a number by 0.10, you're just moving the decimal point one space over to the left. So it's 0.005 moles is how many I have. So how much sodium oxalate do I have? I have 0.005. How much do I need? I need 0.010. So once again, I don't have enough of the sodium oxalate. And what does it tell me? It tells me that the sodium oxalate is the limiting reactant. And so that's what I'm going to use to answer the question. Okay, so this is how much, again, this is how much I have. So that's the number I'm going to use, is how much I actually have. So now I can answer the question. So I'm going to go from oxalate, so 5, from the equation, from the balanced equation, 5 moles of C2O42 minus, and then they're asking us about what? They're asking us about moles of CO2. So CO2 is a 10. So 10 moles of CO2. 10 divided by 5 is 2. 0.005 times 2 is 0.010 moles of CO2. Okay, and so the correct answer is C. All right, we're going to stop there. I'm going to do a couple more examples, but I'm going to do them in a separate video. But that's a good introduction there to a basic stoichiometry free response question, and then a basic free or multiple choice question involving limiting reactants.